Okay, let's do this. Another Calc 3 test. Yeah, I don't know. Yeah, I still don't know. There you go. Okay, find the maximum value. Ooh, sweet. This is another Lagrange multipliers question. Sweet. The gradient of f is equal to 2, 1. Sweet. And then the gradient of g. Oh man, that's a long one. 2x plus 2y. Oh, and then 2x plus 8y. Okay, so we know 2 is equal to lambda 2x plus 2y. And negative 1 is equal to lambda of 2x plus 8y. Okay. So what I'm going to do right here is I'm going to say, let's cancel these out. And I'm going to say that negative 2 is equal to 2x plus 2y over 2x plus 8y. So if we do that, negative 4x minus 16y. So you get 2x plus 2y, which means you get 6x is equal to negative 18y, which means that x equal to negative 3y. Cool. So let's plug that back into this equation. X squared plus 2xy plus 4y squared equals 7. That's an ugly one. Okay, anyways, negative 3y squared plus 2 negative 3y times y plus 4y squared equals 7. So we get 9y squared minus 6y squared plus 4y squared equals 7. So we get 3y squared, 7y squared equals 7. So y squared equals 1. It means that y is equal to plus or minus 1. So now we have to test that again for x. So x squared is equal, so let's test negative y equals negative 1 first. Equals 2x times negative 1 plus 4 negative 1 squared equals 7. So you get x squared minus 2x plus 4 equals 7. So you get x squared minus 2x equals negative 3. Sorry, thinking too ahead. So if we move this to the side, 2x minus 3 equals 0. You just do some simple factoring. Is x minus 3, x plus 1, which means x is equal to 3, negative 1. So your critical points are equal to 3, negative 1, and negative 1, negative 1. Cool, let's test the other one. Y equals to 1. So x squared plus 2x times 1 plus 4, 1 squared equals 7. Which means that x squared plus 2x plus 3 equals 7. Just say x squared plus 2x. That should be a 4. Minus 3 equals 0. Factor it out again. So x this time is equal to x plus 3, x minus 1. So that x equals negative 3 and 1. So your critical points at this point are negative 3, 1, and 1, 1. So now we got to test it with fx again. So f of xy is equal to 3 plus 2x minus y. Okay, so we got to test all of our points. Let me highlight them for you guys, because, oh my lord, because you guys are special. Okay, let's test 3, negative 1 first. So f of 3, negative 1 is equal to 3 plus 6 minus negative 1 equal to 10. So f of negative 1 equal to 3 minus 2 plus 1 is equal to 2. f of negative 3, 1 equal to 3 minus 6 minus 1, which is in this point is equal to negative 4, I believe. And then f of 1, 1 is equal to 3 plus 2 minus 1, which is equal to 4. They asked for a max. This point is 10 because 10 is the biggest number. And that is correct, by the way. I don't have the answer sheet right here, but I just know that's correct. Anyways, that was a long question. Wow, these guys are crazy. Okay, so find f times dr. This is also going to be a long question. Okay, so in this case, you can use the potential. I guess it's the fundamental theorem. Use the potential B minus potential A. So we gotta find the potential first, which means we gotta find the curl. Okay, so we gotta find if it's conservative, not the curl, if it's conservative. Okay, so I usually wouldn't do this. You should just memorize it, but in this case, it's very good to have FGI, which is just equal to h of y minus. Okay, so you can use the cross product, or you can just memorize what I'm about to tell you. Partial derivative of f z g of x is equal to f of y. Okay, so now we gotta test that. I'm gonna highlight these in different colors. So, yep. That's our, oh my lord. That's our f, that's our g, that's our h. Okay, so h of y is negative x, which is equal to g of x, g of z, which is coincidentally also negative x. So, hooray, I don't like this color. I'm going back to green. Okay, so h of x is equal to negative y. F of z is also negative y, so that's also correct. And then g of x is 2x minus z. F of y is also 2x minus z. So once these three are met, we know it's conservative. So now we got to test for potential. Okay, so in order to find the potential, gotta take the integral of f at x, so that would be equal to x squared y minus xy z plus whatever this is, this constant. Wow, this is gonna take a long time. Okay, and then you gotta take the derivative, partial derivative of y. So get x squared minus xz plus x prime of yz equal to, and then you basically got to equal it to g. So g is x squared minus xz, which means that prime is equal to 0. So usually you'd have to then take the integral to find yz, and then you have to find b of z. But in this case, it's equal to 0, so your potential function is actually just equal to x squared y minus xyz. Sweet. Okay, so now we do this. Our point A is 2, 1, 0. Our point B is 3, 2, negative 1. Sweet. Okay, so we just, oh my lord, we just plug these in. So for B, it would be 9 times 2 minus 3 times 2 times negative 1, which is 18 minus negative 6, which is just equal to 24. And then for A, it would just be 4 times 1 minus 2 times 1 times 0 equal to 4. So 24 minus 4 is equal to 20. And that is our answer for 2. That's another long question. Wow, they really hate these students. I am one of these students. What am I talking about? Convert to polar coordinates. Sweet. So since this is dy here, now that's 0 less than y less than square root of 9 minus x squared. So we can say y is equal to 9 minus x squared, so y squared is equal to 9 minus x squared plus y squared is equal to 9, so r squared is equal to 9, means that r is equal to 3. Sweet, that's our first bound, 0 to 3. And since we have this, right, we know that 0 less than x less than 3, since x is always positive, we know it's from 0 to pi over 2, because this angle right here is pi over 2. And then we just convert this, since this is the square root of r squared, since x squared plus y squared is r squared, then it's just r. Then we get r times, remember, dr d theta, r dr d theta. So 0 to 3 of r squared dr is equal to r cubed over 3. 0 to 3 is equal to 81 over 3. Sorry, not 81 over 3. My bad. 27 over 3. Just get you 9. So now 0 to 2 pi of 9 d theta is just equal to 9 times 2 pi, which is, wait, it appears I may have done something wrong. Sorry, I don't know why I wrote 2 pi over 2, pi over 2, which is equal to just 9 pi over 2. And that is your answer for 3. Okay, 4. Calculate this. Okay, straight line segment. You're from 1 to 0 to 5, 3. So you're going to have to parameterize, which just means taking that first vector. So that would be 5 minus 1, 3 minus 0. You get 4, 3. Then you take this first point, which is 1, 0, plus t times that vector. So you get 1 plus 4t, and then that's just 0, so it'll just be 3t. So that's your r of t right there. Okay, following your r of t, you want to find your r prime of t, which in this case is just 4 and 3. Then you want to find the magnitude of your r prime, which is 4 squared plus 3 squares equal to 16 plus 9 equal to square root of 25 equals to just 5. Keep that number in check, because now this whole thing right here is our f. So if we want to find f of r of t, you got to do 1 over x minus y squared. Sweet. So that would be 1 over 1 plus 4t minus 3t squared, which is just 1 plus t squared times 5, because it's the derivative of, sorry, not the derivative, it's the integral of f times the magnitude of r prime of t dt. So we get 5 on this side, 1 over 1 plus t squared dt. And since it's a line, the integral bounds will always be from 0 to 1. Sweet. Now we can solve. So u is equal to 1 plus t. du is just equal to 1. We have that already. So that'll be from 0 to 1. 0 to 1. Wait, no, my bad. That'll be 5. 1 over u squared, which I can convert to 1 so I can convert to negative 2u, which equals to u negative 1 negative, which is equals to 5 times the new bounds, which is now 1 plus 1 equals 2, 1 plus 0 equals 1, 1 to 2 of negative 1 over u, which just is equal to negative 1 over u, 1 to 2, equal to, let me take this over here, negative 1/2 minus negative 1 equal to negative 1/2 plus 1 equal to 1/2. 1/2, remember this 5 is still here, times 5 is equal to 5 over 2. 5 over 2 is our answer, 5 over 2. Okay, question 5. Choose the triple integral in spherical coordinates that represents the volume of the solid bounded by this cone and this sphere. Okay, first thing you should know is that for spherical coordinates, you'll have your triple integral, and then it'll be something times p squared sine of phi ds. So look for that first. This doesn't have a p squared, so it's gone. This doesn't have a p squared, so it's gone. So there you go. You just took out 2 answers immediately. You don't even have to care. Now let's try to find rho. So we know that rho is equal to the square root of x squared plus y squared plus z squared. So rho is equal to the square root of 8 in this case, since x squared plus y squared plus z squared is equal to 8. So our rho is here, square root of 8. So we know that it can't be this one either. So now we're stuck between 2 answer choices. We don't have to care about theta. We just care about our phi. Okay, so we know that z is equal to rho cosine of phi, which is equal to the square root of rho squared, sine squared of phi cosine squared of phi, not phi, dude, I'm so tired, theta, plus phi, oh my god, rho squared, sine squared of phi, sine squared of theta. So we just know this is equal to rho squared sine squared of phi, because cosine theta plus sine theta is equal to 1. So once we square both of these sides, we get rho squared cosine squared of phi is equal to rho squared sine squared of phi. So the rows don't really care, so sine squared of phi over cosine squared of phi is equal to 1, which means that tangent squared of phi is equal to 1, which means that phi is just equal to pi over 4. Only one answer has that, which means our answer is B in this case. Yep. Okay, compute the following integral. You may wish to change the order of integration. You may not wish, you should. Okay, in order to do so. So basically, a thing looks like this. That's y equal to the cube root of x. And it's 2, 3. So it's within these bounds right here. And then x is from 0 to 27. So if we change these up, we get x is equal to y cubed. So except we used to go up and down, now we're kind of like going like left and right-ish. That's the type 1, type 2. So now we're changing it up, so x now goes from 0 to y cubed, while y goes from 0 to, it just goes to 3 now. Okay, so computing this integral, 0 y cubed, 0, 3 of 4e y to the 4th dx dy now. So now that we're computing that, we can just put y4 to the side, 0 to y3, integrate with x, 0y third is just equal to y third minus 0. Once you multiply that in, you get 4y cubed y to the fourth of 0 to 3. Whew, my voice needs a rest. Okay. Basically, what you can do here is you can do u is equal to y to the fourth, which means du is equal to 4y cubed, which, that's not a good color, takes that away. So great. So now you have eu, but remember you still have to take these, so u is equal to 3 to the fourth, which is 81. U is equal to 0 to the fourth, which is just 0. So now your new bounds are 0 to 81, e 81 to the power of 81 minus e0, which is equal to e to the power of 81 minus 1, which is e in this case. Sweet. Find the center mass of the rectangle, yada yada yada, where the density is this. Okay, so what you may find is that all of your x values are just 1 in this case. So you may want to just, once you find mass, just find y bar, because there's a very unlikely chance that it's going to be a, because it's an odd one out. Take that advice with a grain of salt. Basically goes from 0 to 2, 0 to 4, 1 plus y, dx, dy. That's how you find your mass. So that means 1 plus y, x, 0 to 2, equal to 2. So 2, 1 plus y is equal to 2 plus 2y. 0 to 4 of 2 plus 2y is just equal to 2y plus y squared from 0 to 4 equal to 8 plus 16 to 24. Amazing. So you have now found your mass. Let's find our y bar, which includes finding mx divided by your mass, which is 24. And in order to find mx, you gotta find this integral 0 to 0, 4 of y times 1 plus y, dx, dy. So the x stays the same. So once you find all this, 1 plus y, x dx, just 0 to 2. It stays the same, just equals out to 2. So now you got 2 times y plus y squared equal to 2y plus 2y squared. So 0 to 4 of 2y plus 2y squared is equal to y squared plus 2y cubed over 3, 0 to 4 equal to 16 plus 2 times y cubed is 64 over 3. So you get 16. Am I doing this right? Let me just check. Oh, whoops. Sorry, this should be over 2. Where'd that 2y come from? I might be tweaking out. Maybe I am tweaking out. Anyways. Sorry, my bad. I'm not tweaking out. I am not tweaking out. You get 16 plus 128 over 3. So I guess if you take that, 16 times 3 is 48. 48 over 3 plus 128 over 3 is just equal to 176 over 3. When you simplify that by 4, you get 44 over 18. And then if you divide by 2, sorry, I might be tweaking out a little bit. What the hell? I might be tweaking out a little bit. What did I do around here? Let's redo this integral here, right? Shall we? Let's do it from this side. I'm sorry. I appear to be wasting your time. dy dx. Okay. So now you got 0 to 4 of y plus y squared dy equal to y squared over 2 plus y cubed over 3. 0 to 4, you get 16 over 2 plus 64 over 3. So you get 8 plus 64 over 3. And you get 24 over 3 plus 64 over 3 is equal to 88 over 3. Yes. Okay. 0 to 2 of 88 over 3 is equal to 176 over 3. Oh wait, I'm not tweaking out. What am I talking about? Oh my lord. Oh my lord. Okay, anyways. So now you have your mx, right? So mx over m equal to 176 over 3 over 24. It's just 176 over 3 times 1 over 24, which is equal to 176 over 72. When you simplify that down, you get 22 over 9 equals your y bar. There's only one answer choice here with a 22 over 9, which means our answer choice is B. I'm sorry that took so long, guys. My bad. Okay, anyways, let E be the solid region and the first octant in the xy plane. Below the plane, then the iterated integral satisfying this. Okay, so this is kind of a weirdly tricky question, but I believe in us. Essentially, what you should know is that you want to find that dz first. So z is equal to 8 minus 4x plus minus 4x minus 2y. In this case, we then set equal to 0, so you get you want to find your y now because dy goes second. So you get 2y is equal to 8 minus 4x. So you get y is equal to 4 plus 2x. So you can already take out some answers. It won't be that, it won't be that, it won't be that. And now you're just trying to find your x. So now you set this equal to 0. So 4 plus 4x equal to 0. 4 equals to negative 2x. Sorry, not negative 2x. That should be a negative. My bad, guys. Is equal to 2x, which means that x is just equal to 2. So a is equal to 2, b is equal to 4 minus 2x. So our answer for this one is C. Cool. Okay. Rewrite this triple integral in cylindrical coordinates. Remember, that's dr, dz, d theta. So in this case, we see that y is from x to square root of 4 minus x squared, which means that x squared is equal to 4 minus x squared, which means that x squared plus y squared is equal to 4, which means that r squared is equal to 4, which means that r is equal to 2. Now, this doesn't really matter because they're all from 0 to 2 anyways, but I don't know, it's cool. Anyways, you should always know that this is going to be e to the power of negative r squared times r. So take out anything that doesn't have the times r in there. This one doesn't have it. Neither does this one. So you're stuck to 2 answer choices. And now we only need to find what r theta is. So if we look at our x, we know that our x has to be greater than 0. It has to be positive. In this case, that's from 0 to pi over 2. So find which one has pi over 2 in it. I'm sorry, I covered this up. This one has a pi over 2. And our answer choice is D. Sweet. Which vector field corresponds to the one pictured here? Okay, so what you should know is this vector field shows direction. So for example, it'll be like what direction in the x, what direction in the y. So our first point is actually going to be at 0, 0. And if you put any point into these vector fields, it should show up as 0, 0, and that'll be at the point 0, 0. So for example, if I plug a 0, 0 into A, you get 0, 1. That can't be right. If you plug it into B, you get 0, negative 2. That's also not right. But for the rest of these, they'll all give you 0, 0. So we must test another point. I have chosen this point here, which would be the point 1, 1. And if you see, it goes to the right and up. So it should be a positive and a positive at 1, 1. If you plug in 1, 1 here, you get a positive, but you get a negative here. Can't be C. If you plug it in here, you get a positive and a positive here, and you get a positive and a positive here. Now, this does seem very weird, but in this case, the answer is actually E. Now, this one is a little bit hard to explain, other than the fact that it is just like, you just have to look at it and notice that in this case, if it was 1, 1, you would get 1, 5. And if you look over here, it doesn't exactly go 1, 5 by any means. So in this case, our E is correct. It's kind of a weird explanation. What am I typing? What am I writing here? Okay. Anyways, find the volume enclosed by these surfaces. So what we're going to have to do is going to be 0 to 3 of x, 0 to 2 for y, and 1 e plus x for x. And that'll be dz, dy, dx. So now we just solve this. Yeah. So z1 ex plus y, you get ex plus y plus 1, and then 0 to 2 of ex plus y plus 1 dy is just equal to, that is just equal to, the u substitution is x plus y, which means the du is just equal to 1. So I already have that there. So it'll be, u is there. And in this case, you don't actually have to change your bounds as long as you keep it as like this, because it doesn't really matter. But then you get ex plus y plus, and this has to become a y now. 0 to 2 is equal to ex plus 2 plus 2. That is minus ex plus 0 plus 0. So now you got ex plus 2 plus 2 minus ex. And that is from 0 to 3. So in this case, the same thing happens with the u substitution. So you get x plus 2, which is equal to 1. In this case, u is equal to x, du is equal to 1. So I would just keep it in this form. You get ex plus 2 plus 2x minus ex from 0 to 3. You get e to the 5th plus 6 minus e to the 3rd. That's all minus e to the e squared plus 0 minus e 0. So you get e 5th plus 6 minus e cubed minus e squared plus 1. So you get, is that plus? Is that minus? That should be a minus 6. Where did I get a plus 6 from? Minus 2x. My bad. I see. It's at the very start. My bad, gang. I'm very sorry. That should be a -2, and thus that's also a -2. It's a -2. Anyways, you get e minus 6 minus e, so you just combine terms. E fifth, e cubed minus e squared. -6 plus 1 is just -5. And that is, in fact, your answer, which is D. Last question. Given the force field, find the work required to move an object along this ellipse from 2 to 3. Okay. So, basically, you want to find your r prime of t, which in this case is -2 sine of t and 3 cosine of t. Now your f of r of t is equal to -3 sine of t, because that's in the y, and 2 cosine of t. Now you want to do f dotted with r prime of t, which gets you 6 sine squared t. Why is this in vector? Plus 6 cosine squared of t. Just ends up getting you the answer 6. And then in order to find your bounds, you want to see that it starts from 2, 0 and goes up to 0, 3. And it moves up in an ellipse. So if you draw it out, it would kind of look like this, right? But we're only focusing on this area right here. So you could say that it goes from the angle 0 to pi over 2. So 0 t pi over 2 in this case. So now our integration is really simple. It goes from 0 to pi over 2, 6 dt. So that's 6 theta, 0 pi over 2, which just gets you 6 times pi over 2, which is just 6 pi over 2 over 2, which just gets you the answer 3 pi. And that is the answer for 12. Yeah. So, I hope you followed along. I'm very sorry I made a few mistakes in there. Promise it won't happen again. Happy